Hey everybody, this is Larry. This is day 6 of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Today I am in Median, and you can maybe guess from the different background. It is dark right now, so I don't know. I have a good view, but I don't know. Maybe another time I'll show you. But yeah, I don't know what else to say, but it's raining, so I'm back here, just waiting out the rain a little bit. We'll see what happens tonight. We'll figure it out. There's a contest in about an hour. If I'm around, I'll do it. If not, then I might do it a little bit later. Hopefully you're around for that too. Anyway, today's problem, we'll get to it, is remove duplicates from sorted array 2. Okay, so which one is this? Which, well, like what variation is this? Because this name is okay, but okay. Okay, so each unique element appears at most twice. Okay, so what does that mean? Oh, wait, we have to remove it so that, okay, so each element at most twice. Okay. So we'll return 5 and, okay. I mean, I think this is pretty straightforward, I think, in a sense that you just have, I mean, I think it's like almost, I don't know if it's case analysis per se, but because it's like 2 cases, but just have to be careful. I think that's it. You just have a pointer that goes left and right, and then that's it, I guess, right? I don't know if there's anything that complicated per se, at least conceptually. So the idea here is that basically you go left and right, and then you have a pointer that points to what element to change, and then the pointer that, processes the array, and then and then you just do a lot of if statements. I think that's probably it. It is easier said than done in that there can be possible, silliness, but I don't think that conceptually is that hard. So let's get started a little bit. Okay, so then now for I call it the right pointer. Oops, in range of n. Okay, and of course we have a left pointer is 0. Okay. Okay, so let's say we get num sub right? What happens? Well, let's see. Okay, by default, let's skip the first number so we could make the case easier. The first number is never going to be more than once or something like that. So then now we can compare this number to right minus 1, right? If this is the case, what happens? Because if it's not the case, we can just put it in the number. So then here, then num sub left is equal to num sub right, left increment, right? And then continue. Okay, let's say they are the same though. What happens? Well, so if they are the same, because they're sorted, if they're the same, then I guess you just check to see if this is the same as the 2 elements before, right? So if this is of course meaning that this is the case. So if num sub right is equal to num sub right minus 2, right? Then we don't do anything. We skip. Of course, you have to also check that right minus 2 is greater than 0. Otherwise, then we just do this thing again, right? I think this should be good, but maybe it's very easy to get wrong, even if you have the idea right. So that's kind of my worry. And then we return left at the very end. I believe that should be good. At least this works for n is at least 1, because obviously we skipped the first element, right? So yeah, okay, let's give it a spin to at least check to see if it's right for the obvious cases. It might not be. Okay, so I skipped the 2. Why do I skip the 2? So the right in this case, how is that true? Oh, no. Did I just mess up with my indexing? The other one's right though, which is good. But here, why am I missing a 2? I compared the right here and here, and it's not correct. So we set it to this, right? Okay, let's print that way. Okay, so then here it goes the index 2, which is correct, the number 1, and then 4, 0, 1, 2, 3, 4. Did I mess that up? Num sub right is 2, and this one is just for the other answer, but num sub right is 2, which is fine. But why is this? What is going on here? Am I just really batted off by once? Am I doing math weird? 0, 1, 2, 3, 4. But num sub 2 is what? What am I doing wrong? Am I like going blind or something? Oh, I am being dumb, am I not? Because we did it in place, we updated it, and then now it is correct. Okay, I actually messed up here then. Let me think about this for a second. I actually thought about this at the very beginning, but then I thought that, I don't know, I guess the right answer would be to process it backwards maybe, but then it's a little bit awkward. In this case then, let's see. What's the problem is that you are, and it's good that it catches it. You rather have issues catching and testing than, getting a wrong answer first. But let me think about this for a second. I guess we should look at left. Because by definition, if num sub right, yeah, I guess I should check this against left oops. It's left minus 1, because you know that left in that case is going to be the same as this, but this feels awkward. Still skipping it anyway. Because left minus 1. Wait, why is that left minus? This should be. Oh, left is not the last number. Left is the last number. Okay, so I just mixed it up. Okay. And in here it should be left minus 2 actually. The idea is that, and we should draw it out, right? I think that's, so there's nothing magical to what I just did, is just drawing out in my head. Though let's actually double check that it is right before I talk about celebrating. Okay, let's just do this one. And also just do 1 number and 2 numbers and stuff like that. Okay. Okay, so let's give it a submit. That now I'm slightly more confident, and yeah, looks good. Streak 677. Yeah. So if this looks magical to you, I think the idea is just to kind of have, like I always say, I don't have it on me because I did it in my head, but visualize what the pointers are pointing at, and then think about how to go about it, right? And you can visualize this by drawing out as well, of course. But the idea is that, okay, the idea that I had, at least initially, which was wrong, but let's say you have a second array where here, your left and right pointers is going to be the same for the first all the way, and then I guess this is actually a bad example. Oh no, I print out the output, that's why, because the output was not that interesting. Of course the output is going to be good. Okay, so let's look at this number, right? So then the idea is that in your new array, your L is going to always be your last number that you just processed, or at least if num sub right is equal to num sub right minus 1, meaning that the last two numbers are the same. In that case, and technically I guess you could move this to left, but I think in this case it actually doesn't matter. But in num sub right is always going to be, if it's different, then you just increment, right? That's fine, that's obvious. But if they're the same, then that means that the num sub left, the left pointer, is the last number that's added, right? So if you add it right here, then that means that now left, and of course left is actually not pointing at the last number. Left we incremented after the last number, so that is the number. Left minus 1 is the last number added, and in that sense, then this is left minus 1, which is the last number, and you go, okay, so this number is the same as the last number. Do we add this number, right? And so the only case where we don't do that is if the previous number before that is also a 1. So if we have 3 ones in a row, so what this is saying is that if we add num sub right to left, then we're going to have 3 numbers in a row, right? So that's basically the idea, and that should be basically what I did. I think there is a simpler way to do it now that I talk about it like that, is that what you can do is maybe you can do something like, num sub left is equal to num sub, num sub right, left, and then if num sub left minus 1, which is the last number we added, is equal to num sub left minus 2, equals to, and this is equal to the, right? That means that now we have 3 same numbers in a row. Then in that case we just, increment. In that case we decrement it back. I think this should be good as well, and it's the same idea, and actually much cleaner, to be honest. Of course you have to actually check to go, actually surprised at that as well. It may be wrong because I forget to check that, and right. So maybe just like wrapping around and doing some crazy shit, because Python negative indexes are kind of crazy. So yeah, so that looks good as well. So that's probably way simpler, to be honest, than the way that I did it. So let's just go with this. And this is going to be linear time, constant extra space, as you see. I mean, that's the constraints that they give you anyway. So yeah, this is all I have. Let's see what I did last time. Yeah, okay, so that, so this one is the same idea, except for that we don't increment first. So yeah, I don't know why I end up taking a little bit long time for this one. I blame it on getting off the plane and stuff like that. So yeah, anyway, that's all I have for today. Stay good, stay healthy, to good mental health. Stay tuned, and also check out my Instagram if you're curious about my Colombia trip. And yeah, maybe we'll get a drone video at some point. So I'll see you soon. All right, bye bye.